I wanted to introduce you to a few young men today, an Italian, a Frenchman, and a German. So, Alessandro, he was Italian. He was born in about 1745, and he began talking at 4 years old. That's a little bit late, don't you think? But then he learned Latin, French, English, and German before he finished school. So obviously, languages were not really a problem for him. He was just a little bit of a late starter. So you might think he might be a lawyer, but actually he was a scientist and he was very interested in the sciences. And he had done a lot of reading about experiments that Galvani was doing. Galvani was experimenting on frogs' legs. And he took some wire and metal, actually, and he found that he could get the frog's legs to jump when he touched either side with the wire. Now, Galvani thought that that was due to some fluid inside the frog's legs that had some, I think he called electric properties or something. And actually, this was the basis for Mary Shelley's Frankenstein, was the experiment with these frog legs. And so Alessandro really didn't buy the thought that there was some fluid in there. He thought there was some other reason for this. So he set out to do his own experiments, and he found that taking different types of metal and touching it to different portions of the leg is actually what made the frog's leg move, was the different kinds of metals with, of course, some kind of solution in between. And he was actually the one who created something we call the voltaic pile, where it's basically different types of metal. For instance, you can do this with copper and with zinc, with some kind of electrolyte solution in between. And what he found was this would actually create a separation of charges, or it would create some potential energy. And this is actually the precursor to what you know as the battery. And we've named the units of voltage after Alessandro Volta for his work there. Let's talk about Andre for a minute. Andre was a Frenchman. He was born just a little bit later in 1775, and he was born of a wealthy family whose father was a businessman and a government official. He loved history, geography, literature, and science. He studied math, and he actually presented his first paper to the Académie de Lyon when he was 13 years old. I believe it was something about calculus. So he was a pretty sharp guy. Well, he was interested in some studies that Hans Oersted had done when he discovered a connection between electricity and magnetism. So he decided he was going to do a little more work in that area. And he realized that when he had two parallel wires and he put current through each wire in opposite directions, that the parallel wires actually were attracted to each other, which really helped solidify the connection between electricity and magnetism. And his name was actually Andre Ampere, and you're probably familiar with the unit of current called the ampere, or the amp for short, and we've named that after Andre Ampere. So George, let's talk about George. George was German. He was born in 1789, a little bit later than the other two guys, almost entirely self-taught and under the direction of his father, who was also self-taught, and he was very bored with school. He taught, but he was very unsatisfied with that. George was just not a real happy person, to be honest, but he did a lot of great work in the field. His experiments showed that electromagnetic force produced in a wire decreases as the length of the wire increased. And he published a paper describing the conduction of circuits, and that led to creation of Ohm's law, what we call Ohm's law. It is the most important equation in all of electricity and circuits, and you'll learn that next week. But we call that Ohm's law. And we've also named the units of resistance after George Ohm. So Ohm's law is V equals IR, and we'll look at that more next week. But these are people who did some studies that really set the foundation of all we know about electricity today. And notice that all of their work was built upon the work of other scientists, and this is really how everything happens in science is someone takes an experiment to a certain level and then someone else continues that work, thinking of it from a slightly different perspective. So if you're interested in reading more about that, check out chapter 1 of your Boylstad text and or look on the internet. There's a lot of great facts about all of this. But we're going to look this week at voltage and current and finish up our work on ohms. And next week we'll look at Ohm's law.